In this lesson, I want to show you how to define machine properties. Whenever I create a new project, the machine window opens and the definition of the machine properties is required. In the last lessons, I opened an existing machine file. Now I will show you how to define the machine properties for the first time. In the header section, there are fields for the general properties. I enter the machine name, the gear transmission ratio between bottom and top roll. This determines how much the bottom roll turns faster than the top roll. This is important to set the roll drive diameter at the reference point. The working width is the horizontal total available space between left and right stands. It is used after creating rolls to create spacers to fill the remaining width. Next is the spacer diameter and the spacer material. In the drawing, the radius of the spacer is shown. Now we want to define the stands of the machine. If I want to define the properties of a roll forming machine, I use the F button only. F means forming stand. A roll forming machine consists of F stands only. For a tube forming machine, I first use C, that means calibration stand, and then forming stands. Here is a typical tube forming machine. 3 calibration stands. F01 is the welding stand. Then comes the fins and then the breakdowns. I want to define the final stand of a roll forming machine, so I press F1. Now it is a good idea to fill out the stand section that contains the properties of the shafts of this certain stand. This is why later the content will be copied when I press the F button again. The first entry in the stand section is the stand name. If you modify it, it will be shown in the Machine Explorer and, if you want, in the Profile Explorer. Distance to next stand. This is the horizontal distance to the previous stand, opposite the strip running direction. In F01, it is the distance between F02 and F01. It is needed to calculate the stress in the band edges, so it should be filled out before creating the flower pattern. The calibration factor determines how much percent the strip width of the profile should be smaller than the one in the previous stand. It is needed if the rolls press with high pressure in calibration, for instance, sizing or reshaping stands, also in weld forge and fin passes of a tube forming machine. The deformation degree, it is important for the automatic shape of tubes and calibration. It says how the total deformation, 100%, should be portioned to the calibration stands. Normally, the final stand should have a small deformation, less than 10%. In forming stands, this entry field is disabled. In the stand section, you see a column for each shaft: bottom, top, left, and right. I enter the diameter shaft, and in the drawing, the radius will be shown after creating rolls. I repeat this action for the other shafts. Next is the working diameter. This diameter is related to the roll reference point, and in the drawing also the radius is shown. I enter the working diameter for all shafts. For the top roll, you must consider the transmission ratio between bottom and top roll. If you later see that the diameters do not fit, don't worry. You can modify them also after creating the rolls. Now comes the roll reference point. Normally, it should be the same as the profile reference point. In special cases, it may be a different point. I enter the X coordinates for all shafts, and then the Y coordinates. If you are bothered by the top roll's reference point position on the lower sheet side, you can leave the X and Y entry fields empty. Then the bottom roll reference point is taken and moved upward by the strip thickness. Then the top roll's working diameter is a real diameter that can be measured. All shafts can be inclined. If the entry field inclination angle is empty, this means 0 degree normal position. The bottom and top shaft is horizontal, and the side axles are vertical. All shafts and axles can be inclined from the normal position, as might occur, say, in a Turk's head station or a D-twist stand. After filling out the shaft table, I press the F button to create all other stands. During this operation, the content is copied and the machine is defined. Don't forget to provide an empty stand without rolls that represents the position of the flat strip only. Here it is F11. As a result of defining the machine, you see in the drawing 4 red lines. These are the center lines of the shafts and axles. There are several features to modify the properties. You can edit the values in the table. And we'll modify a working diameter, for example. And you can see a different distance in the drawing. Or you can do it in the drawing. Right-click a center line, and context menu opens with several modification functions. A special feature is calculate working diameter from transmission ratio. A window opens, and the proper working diameter is shown dependent on the diameter of the opposite shaft and the transmission ratio. Another feature, if you modify any value and right-click, there is a function, copy to all. The entered value will be copied to all stands. A common practice is to increase the roll diameter slightly in rolling direction in order to create strip tension. This measure avoids vertical buckling and reduces springback of the profile legs between the stands. The function roll lead in the machine main menu decreases the working diameter of the bottom and top roll stands from the current stand opposite the rolling direction by a preset value. All machine data are in the project. They are saved in the project file. If you press the Save button in the machine window, there are Import and Export buttons. These buttons are good to transfer the machine data to a new project that should be designed for the same machine.